So we'll continue our number sense work by looking at number systems and exploring more deeply the binary number system, because that'll help us understand base 10 even better. So we're going to ask that you write your own birthday using binary. My birthday is August 3rd, so 8-3 in typical decimal numbers. In binary, it would be 1000/11, or 1000 is the 8, and 11 is the 3. So we're hopefully going to know exactly why that is after watching this video. All right, so base 10 numbers, we use the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 to represent anything. There is no 10 in base 10, which is kind of strange in terms of the individual numbers. And base 2, we only have two possibilities. We have zeros and ones. That's it. There's no 2 in base 2. So base 10, if we take any numbers like 4,375, what that means is we've got 4 in the thousands place, 3 in the hundreds place, 7 in the tens place, and 5 in the ones place. So basically the way this works in base 10 is starting with the ones, we just are multiplying by 10 to get to the next place value. And another way you'll see this represented is instead of 1 times 10 times 10 times 10, you would see it in terms of exponents. And 10 is, of course, 10 to the first, 100 is 10 squared, and then 1000 is 10 to the third. If we kind of go backwards on that pattern, 3, 2, 1, that would mean the ones place is 10 to the 0. That's getting a little bit more into the algebra perspective of it when you're learning more about exponents. But for now, we'll focus on starting with ones, times 10, times 10, times 10, etc. That's how you move over in place values. So if we're in base 2, if we were to start in the ones place, the next place value would be the times 2, or twos place. And then times 2 again would be the fours place. Times 2 again would be the eights, and then the 16s, and so on. So that's our different place values. Instead of ones, tens, hundreds, thousands, it's ones, twos, fours, eights, and 16s. All right, so let's look at a number in base 2. Let's go with 1, 0, 1, 0, 1. Remember, there are no twos, it's just zeros and ones. So what do we have here? In the ones place, there's a 1. There's nothing. There's a 0 in the twos place. There's a fours place that has a 1. The eights place has a 0. And the 16s place has a 1. So then if we want to see what this 1, 0, 1, 0, 1, what does that represent in what we typically think of, base 10? We have a 16 plus a 4 plus a 1, or the number 21. So 1, 0, 1, 0, 1 is the same as 21 in base 10. All right, how about another one? How about, 1000 is what I had said was the 8, right? Again, we've got the ones place, the twos place, the fours place, the eights place. So we've just got an 8 and nothing else. That's why this is 8. And I said 3 was 1, 1. Well, this is the ones place. This is the twos place. So we've got 1, 2 plus 1, 1, which does equal 3. So that's the same as 3. Let's do one more. How about 1, 1, 0, 0, 1, 1? And let's stop there. So this is our ones place, our twos place, our fours place, our eights place, our 16s, and now we're up to 32. So this number would be 32 plus 16 plus, we don't have any 8, don't have any 4, plus 2, and then plus 1. So 32 plus 16 is 48, 49, 50, and then 51. So this is the same as the number 51 in base 10. So how do you go the other way around? Well, if I wanted to write the number, say, 36 in base 10 and convert that to binary, well, think about my place values. 32, 16, 8, 4, 2, and 1. I'm going to need at least a 32. So I'm going to have to put a 1 in the 32's place. Let's see. So if I subtract off that 32, 36 minus 32 is 4. So I don't have any 16s left. If I need a 4, I don't have any 8s. And then a 4, I could put a 1 there. Minus 4, we got 0. I don't have any 2s, and I don't have any 1s. So the number 36 in base 10 would be the same as 1, 0, 0, 1, 0, 0. That would be 36 from base 10. All right, so that's some base 2, maybe just one little thing, just kind of counting in base 2. If we have just the number 1 and then the number 2, we don't have to move over there. The number 3, and then we can't do anything else now, so number 4, and then the number 5 would be a 4, no 2s, and a 1. The number 6 would be a 4, a 2, and no 1s. Ooh, can't write that. A 4, a 2, and no 1s. The number 7 would be a 4, a 2, and a 1. And then when we get up to 8, it would be an 8, no 4s, no 2s, no 1s, and I'll stop after this one. 9 would be 1, 8, no 4s, no 2s. This was 8, and 1, 1. Okay, so that's some base 2, and hopefully that helps you and allows you to write some numbers, some smaller numbers at least, in base 2.